Hello geometers and seekers of general truths. In this lesson we will study altitudes of a triangle and something called the orthocenter. So I've got some definitions here already, and then we will look at how to construct and draw these segments and points. So an altitude of a triangle, you may have learned this. This is it's often called the height of a triangle as well. But it's a segment from one vertex and perpendicular to the opposite side. And then in a triangle you can have multiple altitudes, and wherever they intersect, that point is called the orthocenter. So let's look at an example of how we would draw altitude and the orthocenter. So I've got a simple looking triangle here, and what I like to do in this image, or this part of the video first, is just show you quickly what an altitude would look like, and then I'll kind of rewind and then show you how I would construct this with a compass and straight edge. So I have the benefit of using my perpendicular tool here. So I just click on a line, click on the point, and this black line right here is perpendicular to this line segment down here. So I've named the triangle ABC. So this black line right here is perpendicular to line segment BC. So this is an altitude. If I repeat this process, and now I have, let me change the colors here, but essentially the black line, the green line, and the blue line are all perpendicular to their opposite sides. It goes from one vertex, from point B in this case, perpendicular to line segment AC, and then from C perpendicular to line segment AB. So all three of these lines in the middle here, they are altitude, or these line segments here, they're all called altitudes. And this point right here would be called the orthocenter. Okay. Now, I want, with this nice computer tool, I want to show you that it is possible for the orthocenter, for the intersection of these 3 points, to be outside of the triangle. And we'll look at some case. It's possible for the orthocenter to be right on one of the vertices, and it's possible for the orthocenter to be outside of the triangle as well. So that's this point right out here. Whoops. This point right out here. I'll emphasize it. This big red point, red dot right here. That's the orthocenter. And depending on what type of triangle we're looking at, the orthocenter could be inside. It could be right on a line. It could be aligned with one of the vertices, and it could be outside of the triangle altogether. Okay. So this is the quick preview of what an orthocenter could look like. I'll post the link to this file so you can play around with it as well. Now I like to kind of rewind a little bit, delete all these things, and talk about how we would produce an altitude and the orthocenter using just a compass and straight edge. Okay. All right, so back to my the original triangle here. With a compass and straight edge, we only have the ability effectively to draw circles or parts of circles, but that's okay, that's sufficient. So this is how we would approach it. Pick some point, or set your compass to put the needle on B and put the pencil somewhere on the opposite side length. So let's call that extra point out here. Okay. Let's call this point D, and it could be really any point as long as your compass is big enough to reach that point from B all the way to D. Then draw a circle with BD here as the radius. Okay. And then notice here my circle is quite big, so maybe you can choose BD a little bit more conveniently. All right. Well, even if it is really big, that's okay. What we want to do now is extend CA so that you get an intersection in there. So I'm going to produce a ray. So I essentially just take using CA and extending that line. And where the ray intersects the circle, call it another point. Call it some other point. I need to make this a better point. Whoops. That's point E. Okay, so now I have a segment DE. And if I find the midpoint of that, and you can use, I'm assuming you already know how to find the midpoint, but if you find the midpoint of ED, that's right there, that's point F. And point F, from F to B, is guaranteed to be perpendicular to line segment AC. Okay, and we can actually test this as well. If I make that angle, that's just that angle tool just helps you to see that that actually is perpendicular to the to the line segment. So recap: put some random point on the opposite line segment. Use your compass from the vertex to that line segment to draw a circle. Make that circle, as long as that circle, if the circle intersects the line segment, then you're fine. If not, just extend the line segment to get this other point that's also on the circle, and then bisect that circle, that line segment, and this point right here is where you want to draw the altitude. Okay. So you repeat that process again, and what you will effectively have is the orthocenter. All right. Now, in this part of the lesson, it's helpful at this point to maybe recap what we've learned so far, whether these segments here are perpendicular bisectors, they are median, or they are altitude, and why or why not. Okay. So here in this case, it's actually none of them. And the reason it's not any of them is because, oops, typed in the wrong spot. It's none of them because this line segment here does touch the vertex, but it is not perpendicular to the opposite side. So the definition here, the operative word here, is that perpendicular to the opposite side. Okay, so that's one thing. It's not a median because it doesn't bisect AC, and it is also not a perpendicular bisector because it doesn't bisect AC. Okay, so in this case, it's none of them. Now in this case, we can see here that this is not an altitude because this angle down here is not perpendicular. It's not 90 degrees, but this line segment BD does bisect the opposite side. So this line is at least a median. It's not a perpendicular bisector because there's not a 90-degree angle there. Okay, and here in this case, it's actually all three of them. It is a median because AC is bisected. It is an altitude because this line segment is going from the vertex to the opposite side and it's perpendicular to it. And since it is both a median and altitude, we can also say the last thing, that it is in fact a perpendicular bisector. Okay. So there you have it, some features, some properties of this special line segment we call the altitude or the height. Now we'll revisit and we'll use this idea quite a bit later on when we go to calculate areas of triangles, but at least now we have a sense of what this thing is and how to construct it and what its properties are. As always, thank you for watching. Ask for help if you need it, and have a wonderful day.